All right, so we're going to continue our walkthrough sequences series with a discussion of a series. And we're going to look particularly at arithmetic and geometric series, but there are a number of different series because a series is really just the sum of the terms in a sequence. So for example, if I said, find the sum of numbers from 1 to 100, and I asked you how you would do that, if you take a minute to think about it, you could start adding them. So you go 1 plus 2 is 3, and then add 3, that's 6. 6 plus 5, or 6 plus 4, sorry, is 10, plus 5 is 15, and you could go up like that. But that would take a while. And if you have a calculator, it wouldn't take that long, but it still would take a while. But there's a really quick way to do this. And the quick way is to notice that 1 plus 100 is 101. So is 2 and 99. So is 3 and 98. In other words, it's a combination of the biggest number and the smallest number, the next biggest number and the next smallest number, and so on, always adds up to the same amount. And you can keep going until you get back to 1 down here and 100. And then the question is just a matter of, well, how many terms are there in that sequence? But you can add them up and know that every sum is 101. And so the quick way of summing this is to go two of these sums, if you add it up twice, they all add up to 101. And there are 100 numbers. We're adding 2 of them each time. So we have 100 divided by 2, because we're going to have pairs of numbers. So there's 50 pairs, and each pair is 101. And so the answer is 5,050. And that is an easy way to do any arithmetic sequence, because any arithmetic sequence works the same way. The terms, because they're separated by a common difference, are always going to add up such that the first term and the last term is the same thing as the second term, and the second to last term is the same thing as the third term and the third to last term as they add together. And so we can write that out like this. We can say, first of all, if we know the last term, that the sum of the terms in the sequence is just the number of terms divided by 2, and then you add the first term and last term together, because there's that many sums. That's the end part of the sequence. So in the last part, it was 100 numbers divided by 2. There were 50 pairs, and each of them added up to 1 plus 100. So 101. If we don't know the last term, then we write Tn out as the formula that we know. The formula is, just to show you where this comes from, T1, that's A, and then Tn is A plus n minus 1d. So if I add those together, I get A plus A, which is 2A, plus n minus 1d. So if we don't know the last term, then we can use this formula. And again, both formulas, all we're doing is we're trying to figure out what is the sum of all the terms in the sequence. That's what we're trying to do. We're just trying to figure out, if we add them all up, what does it give us? And you might be wondering, well, why do I care? Why would I want to sum up the number of terms in a sequence? Well, we'll look at the applications a little bit later, but in more detail. But you can just imagine if you have a theater, and the way that you're designing the theater is sort of in a pattern where you're adding a seat to each row as you go back, so that it sort of pans out like most theaters do. And you want to know how many seats there are in the whole theater. That's an arithmetic sequence. The first row, you can count that, see how many seats there are in that row, and then you can just count your way back every time. Or you could say, well, if it's going up by 1 each time, then I don't have to count all the seats. I can just use this formula to tell me how many seats there are. That's just a simple example, but that's the idea, is that we're taking an arithmetic sequence and now we're actually trying to add it up. So here's an example where it says, find the sum of the series. It gives me the number of terms in the sequence, which is also the number of terms in the series. It gives me the first term, and it gives me the last term. So because I know the last term, I go 3 plus 9, right? That's T1 plus Tn. If I write the formula over here so you can kind of see what I'm doing, it's n over 2, and then T1 plus Tn. So I'm taking T1 and Tn. That's my 3 and my 9. N is 6, and I'm dividing the whole thing by 2. So that gives me 6, 3 plus 9 is 12, and then I'm dividing by 2, and so my answer is 36. If you look down here, this one's slightly different because it says find the sum, but it doesn't tell you how many terms are in the sequence. So if you remember, if we don't know how many terms there are, we find it by assuming that's the difference of 3. So we're going to assume that that continues. We only have 2 terms, so we don't know for sure, but we'll assume that it does. So our first term is 3. Our common difference is 3. And so we can find our Tn as this, 3 plus 3 times n minus 1, which is 3 plus 3n minus 3, which is just 3n. So then we say, okay, 36 is equal to that 3n, then that means n is 12. So we need the sum of the first 12 terms, and then we plug into our sum formula, so it's 12 multiplied by T1, which is 3, or A, we can call it A or T1, and then plus the last term, which is 36, and we're dividing the whole thing by 2. So we end up with 39 times 12 divided by 2, which is the same thing as 6 times 39, which is 240 minus 6, so 234. And that's the sum of my terms. So a little bit more work there because you have to figure out what is n. Here it told us what n was. It said n6. Here it doesn't. You have to find it. But you're using what you used with arithmetic sequences, those questions, to do the same steps here, and then you're just, at the end of it, doing the sum formula. So really all we're adding to what we've already done is just that last step, which is adding the series together. Okay, and here's another example. It says find S20 of this. So we don't know what the last term is. So what we're going to use is the other formula. The Sn is n onto 2a plus n minus 1d, all divided by 2. That's the formula we're going to use. So we're going to plug in 20 for n. Our a is 5. N is again 20. And our common difference is 4. Because it's going up. If you go up here, the common difference, I think you can see that, but the common difference is 4 there, and the difference there is 4. And then we're dividing the whole thing by 2. So that gives me 20 divided by 2 is 10. So I'm just going to put 10 out here. And then it's 10 plus 19 times 4. So 19 times 4 is 76. So we have 10 onto 10 plus 76. That gives me 10 times 86. And that is 860. So the sum of the terms is 860. So that's really the whole concept of arithmetic sequences. Now, you'll notice sometimes that instead of it writing it as an arithmetic sequence, so instead of writing a Tn, those sort of things, it writes it in a different notation. And this notation is called sigma notation. All right? Because this, right here, that symbol, is the Greek letter sigma. So it's another way of representing the sum of. And what sigma does, if you imagine you have sigma of x, then it says, imagine that x goes from 1 to 10. This is a very simple example, but what it's saying essentially is that you're going to start by plugging 1 in there, and you're going to add up plugging the next number, and it goes in order 2, and then 3, and then 4 all the way up. You're going to keep plugging them in until you get to that top number. So the top number is 10. So eventually I'm at 10. And then I have to figure out what that is. Now, in order to figure out the sum, you can use the sum by actually adding these up. So that's 3 and 3 makes 6, plus 4 is 10, plus 5 is 15, 21, 28, 36, and then 45, 55. Okay, or you can notice that there's 11, 9 and 2 are 11, 3 and 8 are 11, 4 and 7 are 11, and 5 and 6 are 11, and there's 5 pairs of them. So in other words, you can use the sum formula from the arithmetic sequences. And so you can use either method. In other words, you could do this. You could say, I want the sum of the 10 terms. Okay, so it's 10 divided by 2 onto the first term, which is 1, plus the last term, which is 10. So that gives me 5 times 11, and that's 55. So there's 2 ways to do it. You can actually expand it and then write it out, or you can use the sum formula. As long as this thing, this Tn, which is normally here, is actually the result of an arithmetic sequence. If it's not, you can't use this formula. You have to use something else. So you have to recognize the form of this as Tn being a linear function. We talked about arithmetic sequences being linear. So for example, here, this is an arithmetic sequence. Okay, so we know that Tn is 2n minus 1. Now, that means that T of 50 is 2 times 50 minus 1, and that's 99. So then I go, the sum of the first 50 terms, because we're starting with the first term, we're going to the 50th term. Because it's arithmetic, I can say it's 50 divided by 2, and then T1 plus Tn. So I need to know what's the first term. Okay, so I go back here and I say T1 is 2 times 1 minus 1, which gives me 1. So A, or T1, is 1, and Tn is now T of 50, so it's 99. So I have this. And that gives me 25 times 100, which is 2500. That's what sigma notation looks like. Now you have to be able to write something in sigma notation as well. And so again, just to reiterate, the way you do that is you just go sigma from n equals 1 up to whatever the last term number is, so up to n of Tn. That's how you write it out. Okay? That's what you would do. So if we look at another example, imagine, I'm going to just imagine this. I want you to write this in sigma notation. We'll just do a couple of those so you can kind of see how this works. So we're going to write, first of all, 2 plus 4 plus 6 plus 8 plus all the way up to 100. So we need the first term is 2, and the common difference is 2. We need Tn because that goes into our sigma notation. So we're going to get 2 plus 2n minus 2. That just gives me 2n. So that's my Tn. And then what I need to know is I need to know the lower limit is 1. I'm going to start at n equals 1. So as I'm populating my sigma, the sigma gets written in. And then I say I'm going to start at 1, and I'm going to plug it into my Tn. And then I need to go, where am I going to stop? And in order to figure that out, I have to figure out what's n when Tn's 100. So I have to say, okay, if 100 is equal to 2n, then n is 50. So I'm going to go from 1 to 50. And that's how I write that in sigma notation. So I find how many terms there are in the sequence or the series, and then I go Tn from 1 up to that number. Okay, so that's how you write things in sigma notation. So that's the concept of sigma notation in arithmetic series. And then we're gonna get into geometric series as well, but that's arithmetic series and sigma notation.